As hinted in our previous module, there's more to the public key model than meets the eye. If Bob creates a public and private key pair, anyone can use Bob's public key to encrypt data for Bob. As the public key has been distributed to the public and the private key is the only key that can decrypt the data, which is kept secure by Bob. In this public and private key pair model, one key encrypts and the other decrypts. So you can encrypt with the public key and decrypt with the private key. But, as may not be expected, you can also encrypt with the private key and decrypt with the public key. Further, if you are able to decrypt with the public key, you know that it could have only been encrypted with the associated private key. Let's take a look at signing in the context of signing a document file that has not been encrypted. First, Alice takes the document and creates a hash value from that document, maybe SHA-256 as discussed in our previous module. This hash value is often referred to as the digest and can uniquely identify the associated data. If any data within the document changes, it will not match that hash. Alice then encrypts that hash with her private key, and this will act as her signature. This will mean that if Bob can decrypt the signature with Alice's public key back to the digest, and the digest matches the document, you validated that that document was signed with Alice's private key. But wait, we need to add a little more drama to this crypto story. What if there's another woman, Sybil, who wishes to break up Alice and Bob? Sybil produces a public-private key pair and gave that public key to Bob, pretending to be Alice. So the final step here is that we need to validate that the public key is really from Alice. Well, this should really be the first step in the process. Once the public key is obtained, it is hashed into a smaller value called a fingerprint. This fingerprint can be used to identify the public key quickly for us slow humans. There are many ways to do this. Some feel comfortable validating over the phone, and others like to do it in person. Perhaps Alice hands Bob a card with fingerprint in person. If the person is currently a stranger, some perform a deeper identity check, including looking at multiple state and federal IDs. In the PGP system, once the fingerprint is validated, you can sign that public key with additional metadata using your private key. This validates the authenticity of this public key. Remember, the level of authenticity depends on the person doing the authentication. Because this process can be a pain, some relinquish responsibility to a certificate authority, CA, or form a web of trust. A web of trust is a distributed instance of a certificate authority using PGP. If Bob trusts Faith, and Faith trusts Alice, then Bob should trust Alice. However, in our case, we'll focus on direct trust. Because the private key is so powerful, it is of the utmost importance to keep it out of adversarial hands. Firstly, it is encrypted and requires a passphrase to decrypt. Additionally, you can create subkeys for signing and encrypting. The idea is to keep the master keys in a very, very secure environment, and you can revoke subkeys if necessary. Just remember, if you forget your passphrase, you'll never be able to use your private key again. But that also means if your device with the private keys gets stolen, it is unusable without the passphrase. Another add-on to this is secret sharing. Secret sharing is a process in which multiple parties need to enter their password or keys to decrypt. For example, any 2 of 5 individuals can authenticate to decrypt and utilize the private key. This can be useful for things such as approving money transfers. Imagine if transfers could only be issued after validating a digital signature, a signature that required more than one agent.